Welcome to Advanced Topics Mathematics. My name is Jeremy Pletcher, the author of The Survey of Mathematics. This is the textbook that we'll be using. As we teach these lessons, I encourage you to follow along, read carefully, work out problems as we do them. We begin our discussion of mathematics with something called natural numbers. Natural numbers are the numbers that we would naturally use in real life. If I go outside and I start counting objects, I am using the natural numbers. 1, 2, 3, 4, and so on. The natural numbers are abbreviated with the letter N. This particular chapter and unit is going to be fairly heavy with terminology at the beginning. One of those terms are the natural numbers. Another term is something we call factors. In multiplication, each number that is being multiplied is called a factor. So if I have 2 times 3, 2 is a factor and 3 is a factor, giving me my final product of 6. To find factors of a number, you need to find out what numbers you can divide by and still have a natural number as your answer with no remainder, or a remainder of 0. So for instance, if I take 16 and I divide by 4, I get a number of 4 as my answer with no remainder. However, if I were to try to take 27 and divide by 4, I would get 6 with a remainder of 3. So those would not be factors of 27. These numbers are also called divisors. So if I go back to something like 16 and I divide by 2, 2 would be the divisor, and my final answer, which is called the quotient, would be 8. 16 divided by 2 is 8. So they can also be called divisors or factors, depending on which way you're going. So as an example, the factors of 50 would be 1, 2, 5, 10, 25, and also the number 50. So the first object that we're going to try to do today is determine the factors of a number. So if we had 98 and I wanted to find all the natural factors, natural numbers of 98, here is the process that I personally use. I begin by taking the first number, the number 1. 1 is always a factor of any number. Now, if I take 98 and divide by 1, I get another factor of 98, which of course is 98. I then go to the number 2. Can I divide 98 by 2? Well, since 98 is an even number, 2 can divide 98 evenly. So if I divide by 2, I get 98 divided by 2, which is 49. So 49 is also a factor of 98. Then I'll go to my next number, the number 3. If I try to take 98 and divide by 3, it will not come out evenly. We'll get 32 with a remainder of 2. So 3 is not a factor. Remember, in order to be a factor, when we do our division, we have to come up with a remainder of 0. If I go to the number 4, I once again cannot divide evenly. Now there are some tricks to figuring out if you can divide certain numbers by other numbers. So for instance, number 3. 9 plus 8 is 17. If I divide 17 by 3, it doesn't come out evenly. Therefore, 98 is also not divisible by 3. So if you take the digits and add them all together, if that sum of all those digits is divisible by 3, then the number itself is divisible by 3. The trick for a 4, if a number is divisible by 4, then the last 2 digits should be divisible by 4, or the last 2 digits are zeros. Now in this particular case, I would just have to try 98 divided by 4. It doesn't come out evenly. The trick for 5, most people already know. The last digit has to end in a 5 or a 0. So obviously 98 is not some multiple of 5. I can go on to 6, but since 98 is not divisible by 3. It cannot be divisible by 6. If I go to 7, I do find that I can divide by 7. There is no trick to figuring out whether a number is divisible by 7. You just have to try it. If I divide 98 by 7, I get an answer of 14. So 14 is also a factor of 98. If I go on to 8, the trick for that is the last 3 digits need to be divisible by 8. However, since it's not divisible by 4 and 8 is a multiple of 4, I know I can't divide by 8 either. If we go on to 9, 9 does not work because the sum of the digits, 9 plus 8, 17, 17 is not a multiple of 9 either. I can go on to 10, 11, 12, 13, and eventually I reach back up to 14, which is where I can end. So I use what I refer to as the sandwich technique. I start on the outer edges and I just move myself inward until my numbers meet up. So in this particular case, all the natural numbers of 98 are 1, 2, 7, 14, 49, and 98. Let's try another. How about the factors of 36? If you need to, pause the video and work out this problem. Alright, so with 36, I start off again with a 1. 1 and 36, the number itself. 36 is an even number, which means I can divide by 2. That would give me 18. Is it divisible by 3? Well, 3 plus 6 is 9, and 9 is divisible by 3, so 36 is also divisible by 3. That gives me an answer of 12. If I divide by 4, I get 9. And then if I divide by 6, I get 6. 5 is not a multiple of 36 because it does not end in a 5 or a 0. So finding all the factors of 36, I get 1, 2, 3, 4, 6, 9, 12, 18, and of course the 36 number. Now let's try 71. Obviously 1 and 71 are going to be factors. It's not even, so I cannot divide by 2. If I try 3, well 7 plus 1 is 8. 8 is not a multiple of 3. Going on to 4, it's not even. Going to 5, it doesn't end in a 0 or a 5. And keep on going. You will discover that the only factors of 71 are 1 and 71. Try 47. If you look through the numbers for 47, you'll discover once again that there are only 2 factors, 1 and 47. These last two are examples of what we call prime numbers. So prime numbers are natural numbers that have only 2 factors, the number 1 and the number itself. So some examples of prime numbers: 2, the only even prime number; 3, 5, 7, 11, 13, 17, and the list goes on. These are prime numbers. Other numbers can be classified as composite numbers. Composite numbers are natural numbers that have at least 3 factors or more than 2 factors. Some examples of composite numbers would be like 4, 6, 8, 9. With the number 4, you have factors of 1 and 4, but you also have factors of 2 and 2. So it has 3 factors, 1, 2, and 4. And you'll see the same type of scenario with all of these other numbers that I have listed. And that brings us to the number 1 itself. 1 is not considered prime or composite. It's not composite because it has only the 1 as a factor, so it does not have 3 or more factors. At the same point, it's not a prime number because it consists of only one number, the number 1. Whereas prime numbers have 2 factors, 1 and the number itself. So the number 1 is an unusual situation where it is not prime or composite. So let's try to figure out if these numbers are prime or composite. We begin with 300. Obviously 1 and 300 are 2 factors of 300, but are there more? If there are more, then that means this number is composite. If the only factors are 1 and 300, it would mean that this number is prime. In this particular case, it is an even number, so we know that 2 is a factor of 300. Therefore, we would classify it as composite. There are a lot of other numbers that are also factors in 300. But once we hit 3, we know we have a composite number. If we try 75, obviously 1 and 75. Are there other factors, however? Yes, there are. 3 and 25, 5, 15. So there are several more factors. Therefore, this number would be considered composite. If we go to 39, 39 is one that tricks a lot of students. 1 and 39 obviously are factors, but are there others? There cannot be a 2. However, it is divisible by 3. Remember our little trick. 3 plus 9 is 12, and 12 is divisible by 3. Therefore, 39 is also divisible by 3. 3 and 13 give us 39. So this number here would also be considered composite. If we go to 53, obviously 1 and 53, but are there others? If you start going through, you will discover that this number is prime. It only has 2 factors, 1 and 53. But be careful, had I put 51 up there, 51 is a composite number. 3 and 17 are also factors of 51. So be careful as you're working. That brings us to multiples. Multiples are numbers found by multiplying a digit by some other counting number or natural number. So as an example, the multiples of 8 are 8, 16, 24, 32, 40, and so on. I find this by taking 8 times 1 gives me 8. 8 times 2 gives me 16. 8 times 3, 24. 8 times 4, 32, and so on. An easier way, one that most students use, will say, well, I start off with 8. I'm going to add another 8 to get my next number, which gives me 16. I'm going to add another 8, which gives me 24, another 8, which gives me 32, so on and so forth. Be careful doing it that way, however. You probably want to check your last number to make sure that it does work out. Because if you miss add just one time, it's going to throw your numbers off from that point on. So just be aware, but it is a very usable method. What are the first 5 multiples of 3? You can probably do it very quickly in your head. We start off with our first number, that number of 3. We're going to get the next 4 numbers. 3 times 2 is 6, and so on. Or we can take 3, add 3 to it, give us 6, add 3 more, give us 9, add 3 more to get us to 12, add 3 more to get us to 15. What are the multiples of 7? We start off with 7. If we were to double that, we would get 14. If we were to add another 7 to that, we'd get 21, followed by 28 and 35. And just as a quick check, if I take my last number, 35, and I divide by 5, I do indeed get 7. So 5 and 7 are both factors of 35. What are the first 5 multiples of 10? In elementary, you more than likely counted by tens at some point, 10, 20, 30, 40, 50, and so on. So those are all multiples of 10.